Hello, this is Nefi Varela, and this is the second part for this video, the third question in this fourth unit about the kidneys and the lungs. And now I'm gonna describe how oxygen and carbon dioxide exchange works, okay? So the main idea is that we want to take oxygen from the outside to the inside of our lungs, that it can be distributed to tissues, organs, cells by the blood. And now carbon dioxide is going to be a product of metabolism. And it's not really good because it is increased acidity, and acidity is not good for most of our tissues. Okay. So we want to secrete it. We want to excel, like to take it out of our body. So what's going to happen? And that's what this diagram is describing. Now we're going to take oxygen from the inside, from the exterior, I mean, from the outside. And that one is going to cross to the vasculature. Okay, so in these capillaries, two things are going to happen. 2% is going to be dissolved in plasma. As you can see, oxygen doesn't have a high affinity. It's not really soluble for plasma. But the rest of it, the 80% of it is going to attach to this structure named hemoglobin, that I'm going to talk more about it in a second. In the case of carbon dioxide is going to become bicarbonate by a chemical reaction. And the other 7% is going to dissolve in plasma, and 23% is going to attach to hemoglobin. Okay. And by attaching to hemoglobin, carbon dioxide is gonna, well, hydrogen by attaching to hemoglobin is going to decrease the affinity for oxygen to attach for hemoglobin. Like, it's like in a bus, when you take a seat, you take someone else's opportunity to, that's it. That's pretty much it. So hemoglobin has this protein, alpha 1, alpha 2, beta 1, beta 2, and an iron Fe in the middle. Okay. For each protein, we're going to have a binding site for oxygen. Okay. So that's what I'm saying, that hemoglobin can carry oxygen to take it to the rest of the body. But to do so, there are two states by which hemoglobin can be, that is going to increase or decrease the affinity, its affinity to oxygen. Okay, so T state, this one is going to be deoxygenated. The way that I like to think about it is, when you are really tension state, you feel that you are suffocated, that you don't have air, right? So tension state, deoxygenated. Though it's not able to bind to oxygen. Our state is a relaxation state. When you are relaxed, deep breaths, that's the way that I like to remember. So we have higher affinity for oxygen. Okay, there are gonna be some things that are gonna help us to transit from the T and R state. The first one is the pressure of oxygen. Okay, so if we have more pressure in oxygen, if we have more oxygen, we're going to increase the affinity, its affinity to hemoglobin. The other one is pH. Okay, by decreasing pH, that means that we are making this more acidic, the blood more acidic. By making the blood more acidic, that means that we are doing two things, or decreasing bicarbonate or increasing carbon dioxide, that is going to increase hydrogen. Okay, so by decreasing pH to making it more acid, hydrogen has the chance to binding with this protein, taking the place of oxygen to be there. So we are going to decrease hemoglobin affinity. Okay, the other one, temperature. Temperature can denature proteins. So if we increase temperature, we can denature these proteins, decreasing hemoglobin affinity. And finally, 2,3-DPG, BPG. This is going to be a product of metabolism, I think glycolysis. And this is going to decrease also HB affinity. Okay, So this black line represents normal saturation and pressure of oxygen, okay? Now, we can have higher saturation by increasing affinity, and we can have lower saturation by decreasing affinity. By decreasing affinity is going to be this is going to happen when we decrease acidity, when we decrease DPG, when we exercise, because we are producing more CO2, we're doing more metabolism, and by decreasing temperature, okay? So that's going to make a more relaxed state, more affinity for oxygen. So we're going to saturate it more. In the other hand, this is going to be the opposite. When we increase CO2, when we increase acidity, when we increase DPG, when we do more exercise, when we do temperature, increase temperature, we're going to have more tension state, more T state. So we are going to decrease that affinity for oxygen to attach to hemoglobin. Pretty much it. Until now, I have just described what's going to happen with oxygen that is going to enter, that is going to dissolve, that is going to take by hemoglobin. Some of it is going to, well, hemoglobin has to stay tension and relaxed state that is going to messed up with the affinity of oxygen to attach to it. But now what's going to happen with carbon dioxide? This diagram is showing it. But pretty much it is going to happen the following. So now we have CO2 that is going to become bicarbonate by a chemical reaction. Now, in this reaction, we will have some products, bicarbonate, hydrogen. Hydrogen is going to travel to the blood, hemoglobin. Inside of the red blood cells, we will secrete CO2 that finally is going to be secreted by our body by expiration. So that's pretty much it. CO2, bicarbonate, H travels in hemoglobin, CO2 goes out, and that's pretty much it. So that's how it works. Oxygen in, carbon dioxide out. I hope you liked my video, and that's it for the third question.